The surface of our planet is not one solid rock, but a patchwork of massive slabs, known as tectonic plates. These plates form the lithosphere, the rigid outer shell of the Earth, and float slowly on the semi-molten asthenosphere beneath them. Their constant motion is what shapes the landscapes we see today. Mountains rise, oceans spread, earthquakes strike, and volcanoes erupt, all because of tectonic plates. Scientists have identified two types of plates: major plates and minor plates. Major plates are the giants, covering both continents and oceans. Minor plates are smaller, but they also contribute to Earth's activity. The movement of these plates can be convergent, colliding, divergent, moving apart, or transform, sliding past each other. These movements create powerful geological phenomena. In this series, we will explore the 8 major tectonic plates of the Earth: the Pacific Plate, North American Plate, South American Plate, African Plate, Eurasian Plate, Antarctic Plate, Indo-Australian Plate, and Nazca Plate. Each of these plates has its own unique role in shaping the Earth's geography. By the end, you will see how our planet is a living, moving system. Let's begin with the largest one, the Pacific Plate. The Pacific Plate is the largest tectonic plate on Earth, covering more than 100 million square kilometers. It lies beneath the Pacific Ocean and is mostly oceanic in nature. Because of its size and activity, it plays a central role in shaping the geology of our planet. The Pacific Plate is constantly moving, mainly in a northwest direction, at an average speed of 7 to 11 centimeters per year. One of the most important features of the Pacific Plate is the Ring of Fire, a belt of volcanoes and earthquakes. Surrounding the Pacific Ocean, around 75% of the world's active volcanoes are located here. Earthquakes in Japan, tsunamis near Indonesia, and volcanic eruptions in Hawaii are all results of the Pacific Plate's movement. Its boundaries interact with other plates such as the North American Plate, Eurasian Plate, and Indo-Australian Plate, leading to destructive subduction zones and transform faults. The Pacific Plate is shrinking in size because it is being subducted beneath surrounding plates. Over millions of years, this shrinking could significantly change the shape of the Pacific Ocean itself. The North American Plate is one of the major tectonic plates covering most of North America, parts of the Atlantic Ocean, Greenland, and parts of Siberia. It is both continental and oceanic, making it a diverse plate. This plate is significant because it influences much of the geological activity in North America. One of the most famous features of this plate is the San Andreas Fault in California, where it meets the Pacific Plate. This transform boundary is responsible for frequent and sometimes devastating earthquakes. Apart from that, the eastern boundary of the plate lies in the Atlantic Ocean, where it is spreading away from the Eurasian Plate along the mid-Atlantic ridge. The North American Plate moves roughly westward at about 2 to 3 centimeters per year. This movement is slow, but powerful enough to reshape landscapes over millions of years. The Rocky Mountains, Appalachian Mountains, and earthquakes in Alaska are linked to its boundaries. Overall, the North American Plate not only shapes the land we live on, but also demonstrates the power and constant motion of Earth's lithosphere. The South American Plate covers the entire South American continent and extends eastward into the Atlantic Ocean. This plate is especially famous for its interaction with the Nazca Plate along the western boundary. Oceanic Nazca Plate subducts beneath the continental South American Plate, forms the mighty Andes Mountains, the longest continental mountain range in the world. This subduction zone is also responsible for frequent and powerful earthquakes in countries like Chile, Peru, and Ecuador. The 1960 Valdivia earthquake in Chile, the most powerful ever recorded, was a result of this boundary. On the eastern side, South American Plate diverges from the African Plate along the mid-Atlantic ridge, causing the Atlantic Ocean to grow wider every year. The plate moves westward at an average speed of 3 centimeters per year. Its geological activity has shaped South America's rich landscapes. From the Amazon basin to the Andes, the South American Plate is a clear example of how tectonic forces can build towering mountains and trigger massive natural disasters. The African plate is unique because it contains both continental and oceanic crust. It stretches across the entire continent of Africa and parts of the Atlantic and Indian Oceans. The African plate is slowly moving northeast at a rate of about 2.5 centimeters per year. One of its most significant features is the Great Rift Valley, where the plate is slowly splitting apart. This rift zone may eventually form a new ocean in millions of years. Along the northern boundary, the African plate collides with the Eurasian plate, creating mountain ranges such as the Atlas Mountains and causing earthquakes in the Mediterranean region. The eastern boundary interacts with the Indo-Australian Plate, giving rise to volcanoes like Mount Kilimanjaro and Mount Kenya. The southern boundary with the Antarctic Plate also contributes to oceanic spreading. The African Plate's activity shows that continents are not fixed. They move, split, and change. In the distant future, Africa could look very different due to this continuous tectonic motion. The Eurasian Plate is one of the largest tectonic plates, covering most of Europe and Asia, except the Indian subcontinent. It includes both continental and oceanic crust. This plate is particularly important because it interacts with many others, such as the North American Plate, Pacific Plate, and African Plate. Its collision with the Indo-Australian Plate gave rise to the Himalayas. The tallest mountain range on Earth, Mount Everest, the highest peak in the world, is a direct result of this ongoing collision. In northern Europe, the plate interacts with the North American Plate along the Mid-Atlantic Ridge, where new crust is formed. The Eurasian Plate moves slowly to the east at about 2.5 centimeters per year. This slow but steady motion continues to reshape Asia and Europe. Earthquakes in Turkey, volcanoes in Iceland, and mountains in the Alps all result from this plate's activity. The Eurasian Plate is a reminder of how tectonic forces can create both breathtaking landscapes and devastating natural events. The Antarctic Plate covers the entire continent of Antarctica and extends outward into the surrounding oceans. It is almost completely surrounded by divergent boundaries, meaning it is constantly creating new oceanic crust as it moves away from neighboring plates. Unlike other plates, the Antarctic Plate has relatively fewer earthquakes and volcanoes, but it plays a major role in the global system of seafloor spreading. Its interaction with the South American Plate, African Plate, and Indo-Australian Plate contributes to the growth of the Southern Ocean. The Antarctic Plate is moving slowly northward at about 1 to 2 centimeters per year. Despite being covered mostly by ice, it has active volcanoes, such as Mount Erebus, which prove that tectonic activity is present even in the coldest places on Earth. This plate is critical for scientists studying climate change because its stability influences ocean currents and global sea levels. It shows that tectonic plates not only shape land, but also impact global climate systems. The Indo-Australian Plate is a combination of two smaller plates, the Indian Plate and the Australian Plate, that fused together millions of years ago. It covers Australia, the Indian Ocean, and extends into Asia. This plate is most famous for its collision with the Eurasian Plate, which created the Himalayas. The Indian subcontinent is still moving northward, pushing the mountains higher every year. This ongoing collision makes the Himalayas one of the most tectonically active regions in the world. The Indo-Australian Plate also contributes to frequent earthquakes in regions like Nepal and northern India. In the Indian Ocean, its boundaries with other plates can trigger massive tsunamis, such as the devastating one in 2004. It moves northward at about 5 to 7 centimeters per year, making it one of the fastest moving plates. This constant motion continues to reshape Asia and the Indian Ocean basin. The Nazca Plate is a small but powerful oceanic plate located in the eastern Pacific Ocean. It is especially important because of its interaction with the South American Plate, as it subducts beneath the South American Plate, creates the Andes Mountains, and triggers frequent earthquakes and volcanic eruptions along the western coast of South America. The Nazca Plate moves eastward at about 7 to 10 centimeters per year, making it one of the fastest moving plates. This fast motion is why the west coast of South America is one of the most tectonically active regions in the world. The subduction of the Nazca Plate is also responsible for the Peru-Chile Trench, one of the deepest oceanic trenches on Earth. The powerful earthquakes and volcanic activity in Chile and Peru remind us of the immense power of this relatively small plate. Though small in size compared to giants like the Pacific Plate, the Nazca Plate proves that even minor players can have massive geological impacts. Tectonic plates are the engines driving the Earth's geological activity. From the vast Pacific Plate to the smaller Nazca Plate, each one plays a vital role in shaping our planet's surface. Mountains, oceans, earthquakes, and volcanoes are all results of these massive moving slabs. Through the Pacific Plate's ring of fire, the Himalayas formed by the Indo-Australian Plate, the Andes created by the Nazca Plate, and the Rift Valleys of Africa, we see the dynamic nature of Earth. These processes take millions of years, yet their effects are visible every day. Understanding tectonic plates not only helps us appreciate Earth's beauty, but also prepares us for natural disasters, like earthquakes and tsunamis. By studying them, scientists can predict and reduce the risks of such events. The story of tectonic plates reminds us that our planet is alive, constantly moving, changing, and evolving. The land we live on today may look very different in the future, shaped by the endless dance of Earth's plates.